Hey guys, welcome to Coronavirus Earth Science. We're in Unit 9 Weather and we're on Day 2, Methods of Heat Transfer. Just a reminder, this is your homework. We got a little worksheet at the end of this unit, at the end of this lesson, but these are the two things that you are getting graded on this week. You got your post-test of geologic history that will count as a grade, and then you have the Google form, which again is kind of an experiment. I'm kind of fiddling around with it. I threw that up yesterday, so maybe you guys can take a look at that. It's only 10 questions, get it done. Okay. Sorry about that. Here we go. So this is going to be in your Earth Science reference tables, page 13. And it's very similar to the other one, where it's Fahrenheit, Celsius, Kelvin. This is just talking about pressure now. You're converting from millibars to inches of mercury. Now be careful here. Remember what I said, know what they're going up by. Millibars is going up by 1, and inches of mercury is going up by 0.01. All right, this is 0.60, 0.61, 0.62, 63, 64. All right, so it's going up by 0.01s. So here, if you're going at 29.65 inches of mercury, so 29.65, what's that going to be in millibars? You just look right over here. Okay, so that's an easy one. And then the next one, most water vapor enters the atmosphere. How does the water enter the sky? All right, and most of you should remember this from your basic water cycle stuff, which you learned last year. That's going to be your evaporation and transpiration, which will definitely go into the water cycle again later on. All right, so 3 ways that heat gets transferred, the way that heat flows. And the first way is conduction. And you guys should think of the word conductors, right? Not the guy that drives the choo-choo train. I'm talking about metals, right? Metals are good conductors because they allow heat to travel through them very well. So when we talk about conduction, we're talking about how solids allow heat to flow through them. And when we talk about this, there has to be contact. They're touching. All right, so you should think of solids, you should think of metals, and you should think of touching. All right, so look, the heat is going to go from the hot part of where the flame is, and it's going to go towards the cold part. So eventually, this person's going to burn their hand. All right, you make a cup of coffee that's hot, and you keep your spoon in it. It's going to go from hot to cold, and eventually the spoon will be very hot. There is direct contact. All right, next one is convection, and you should totally be thinking of convection currents, right? So this is nothing new. It's just another way of heat transfer, which is exactly what we were talking about when we were talking about in the asthenosphere, right? Heat is traveling through liquids or gases due to temperature and density differences. Remember, they heat up and then they cool down, making those convection cells. But make sure that you know it's liquids or gases, and the reason why they heat up is because the molecules spread apart and they become less dense, right? And that's why they rise. And then when they cool off, they get more dense, and then they sink. All right, so it's always going to go up over the hot part. Okay, so right here in this picture, let me get rid of my writing a second. It's going to go up over the hot part, and then it's going to go down where it's going to cool. Now, a common question that I've seen before is they'll just move the flame. Just remember, it's always going to go up over the hot part and down on the cold part. Okay? Then you have radiation. Radiation is the transfer of energy through open space. It's going to be electromagnetic waves. And the key thing here is that it requires no medium. It doesn't need a liquid to go through. It doesn't need a solid to go through. It can just go through open space, open air, okay? So this is how the sun heats up Earth, right? You have that heat and electromagnetic waves traveling through open space, which is a vacuum, right? All right, so how is heat going to flow in the system? Take a look at the two cups. Here's 60 degrees, here's 20. This is hot, this is cold, right? And we always say heat flows from hot to cold. Well, how is the heat from cup A going to get to cup B? It's going to go through the aluminum bar, which is a solid, so that means it is conduction. Now, is some heat going to escape? Yes, it is. This is not all enclosed, right? This is what we call an open system. So there will be some heat escape. If it was a closed system where everything was basically insulated, then the heat would go from A to B, and then they would eventually be equal. Okay? So here we go. Heat source to the sink, which is what we just said. This temperature is going to get colder, right? Because it's losing heat. This one's going to get hotter because it's gaining heat. Open system, some energy will be lost, which is what this is. If it's a closed system, the energy lost is 100% gained by the colder object. So they will end up at dynamic equilibrium. So the goal is to have cup A and cup B be the same temperature. All right, that's what dynamic equilibrium would be. Okay, basically, yeah. All right, so here we're just going to go through these real quick, and then I'll let you handle the rest. So in this diagram in number 1, let's start with A. You got your circles, right? That's convection. Through a solid object is conduction. Open space, radiation. Over here, number 2, circle, that's your convection. Number 3, open space, radiation. 4, circle, convection. 5, the heat is going from this section A to B because they are touching. That's your conduction. 6, the heat's going from this side of the bar to this side of the bar. That's conduction. Okay? Here's another one. So here is A, where the water is 50, and B, where the water is 5 degrees. And you have a metal dividing wall, which is here. And remember, metals are good conductors. When the temperature of the water in compartment A goes down by 10, so if this goes down by 10, what do you think is going to happen to compartment B? If it loses 10, where did the other 10 go? It should go to B, right? And notice this is all insulated. So this is what we would call a closed system. No heat was lost, okay? Now we have this one where, look at where the flame is. How are the convection currents going to be drawn? Remember, it always goes up over the flame and down on the other side. So you should have 1. Okay? That's that. Make sure that you finish the other worksheet that's in that folder. And I will post an answer key. Make sure that you guys get the Google form done and the Castle Learning done. Have a great day.